NEC Section 430.102b states that branch circuit disconnecting means for variable frequency drives, or VFDs, shall not be installed in the same enclosure with the VFD unless the enclosure is designed to provide adequate space for the items listed in NEC Section 430.10a. NEC Section 430.10 outlines what enclosures for motor controllers and disconnecting means shall contain. Firstly, control devices. Secondly, associated push buttons and indicating devices. Thirdly, disconnect devices. Fourthly, control transformer and its overcurrent protective device. Fifthly, wiring devices. Sixthly, terminal blocks, fuses, switches, or other devices. Each motor disconnect must have sufficient space for firstly, conduit or wire terminations, secondly, disconnect handle operation, and thirdly, ventilation. VFD generate heat during operation. If the enclosure is not large enough, the heat generated by the VFD may cause the motor disconnects to overheat. The enclosure should provide easy access for maintenance and troubleshooting of the motor disconnects and VFD. NEC Section 312.2 states that enclosures shall be suitable for the environment. In industrial or commercial installations, the enclosure may need to be rated for dust, water, or other hazards. NEC Section 312.5c requires grounding means shall be provided for the enclosure and any non-current carrying metal parts. NEC Section 430.113 requires enclosures to be marked to identify their purpose and the equipment contained within. While it is generally acceptable to place multiple motor disconnects in a single panel door, there are several factors to consider, including space requirements, heat dissipation, maintenance, accessibility, and NEC code compliance. One must ensure that the panel is large enough and designed appropriately to meet all applicable requirements. It is recommended to consult with an electrical engineer or qualified electrician to determine the suitability of this arrangement for one specific application. When placing multiple motor disconnects within a single panel door, it's crucial to meticulously account for several key factors to ensure safety, compliance, and operational efficiency. Firstly, space requirements are paramount. NEC 430.10 and 312.7 dictate the necessary space for enclosures housing motor controllers and disconnecting means, and these requirements must be strictly adhered to. Each disconnect needs adequate room for conduit or wire terminations, smooth handle operation, and proper ventilation. Cramped conditions can lead to difficulties in maintenance, increased heat buildup, and potential safety hazards. Secondly, heat dissipation is a significant consideration, especially when VFD are involved. VFDs, as mentioned, are known to generate substantial heat during operation. If the enclosure is insufficiently large or properly ventilated, the accumulated heat can cause the motor disconnects and other components to overheat. This overheating can lead to premature component failure, reduced efficiency, and even pose a fire risk. Therefore, a thorough thermal analysis might be necessary to determine the appropriate enclosure size and ventilation strategy. Thirdly, maintenance and accessibility are vital for long-term operational reliability. The enclosure should be designed to provide easy and unobstructed access for maintenance personnel to inspect, troubleshoot, and repair the motor disconnects and VFD. Poor accessibility can result in increased downtime, higher maintenance costs, and potential safety risks during maintenance activities. Consider the placement of components, the layout of wiring, and the use of hinge panels or doors to facilitate access. Fourthly, NEC compliance is non-negotiable. Several NEC articles pertain to the installation of motor disconnects and VFD, and adherence to these articles is mandatory for ensuring safety and code compliance. Besides NEC 430.10, 312.7, 430.102b, 312.2a, 312.5c, and 430.113. Also consider articles related to grounding, overcurrent protection, and conductor sizing. Engage a qualified electrical engineer or inspector to review the design and installation to ensure compliance with all applicable codes and standards. Additionally, environmental considerations play a crucial role. NEC 312.2 emphasizes the need for enclosures to be suitable for the environment in which they are installed. In industrial or commercial settings, enclosures might require specific ratings to protect against dust, water, corrosion, or other environmental hazards. Selecting the appropriate enclosure material and construction is essential for ensuring the long-term reliability and safety of the motor disconnects and VFD. Furthermore, proper labeling and identification are necessary for facilitating safe and efficient operation and maintenance. NEC 430.113 mandates that enclosures be clearly marked to identify their purpose and the equipment contained within. This labeling should include information such as voltage ratings, current ratings, and any other relevant specifications. Clear and accurate labeling helps prevent confusion and ensures that personnel can quickly and easily identify the correct disconnects and equipment. Lastly, consider the potential for future expansion or modifications. Designing the enclosure with some extra space and capacity can accommodate future additions or changes to the motor control system. This foresight can save time and money in the long run by avoiding the need to replace the entire enclosure when modifications are required. In summary, placing multiple motor disconnects in a single panel door is feasible, but it necessitates careful consideration of space requirements, heat dissipation, maintenance, accessibility, NEC code compliance, environmental factors, labeling, and future expansion possibilities. Engaging a qualified electrical engineer or electrician is crucial for ensuring that the design and installation meet all applicable requirements and provide a safe and reliable motor control system. It's important to consider the specific characteristics of the motors being controlled, including their horsepower ratings, voltage levels, and full load currents. This information will help determine the appropriate size and type of motor disconnects to use. For motors under 3 horsepower at 460 volts, standard horsepower rated disconnect switches or molded case circuit breakers can be used as the disconnecting means. The disconnects must have an ampere rating not less than 115% of the motor's full load current rating as specified in NEC 430.110. It's also essential to consider the interrupting rating of the disconnects. The interrupting rating must be sufficient to safely interrupt the available fault current at the point of installation. This information can be obtained from the local utility company or by performing a fault current study. When using VFD to control the motors, it's important to select disconnects that are rated for use with VFD. VFD can generate harmonic currents that can damage standard disconnects. VFD-rated disconnects are designed to withstand these harmonic currents and provide reliable operation. In addition to the disconnects, the enclosure must also be properly sized and rated. The enclosure must have sufficient space to accommodate the disconnects, wiring, and any other associated components. The enclosure must also be rated for the environment in which it will be installed. For example, if the enclosure will be installed in a wet location, it must be NEMA 4 or 4X rated. It is also critical to ensure that the enclosure is properly grounded in accordance with NEC Article 250. Proper grounding helps to prevent electrical shock hazards and ensures the safe operation of the equipment. Furthermore, it's essential to consider the wiring methods used to connect the motor disconnects and VFD. The wiring must be sized and installed in accordance with NEC Article 430. The wiring must also be protected from physical damage. Common wiring methods include conduit, cable tray, and direct burial cable. The specific wiring method used will depend on the application and the local codes and regulations. When installing the motor disconnects and VFD, it's important to follow all manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper installation and operation of the equipment. Failure to follow the manufacturer's instructions can void the warranty and may result in unsafe operating conditions. Finally, it's important to perform regular maintenance on the motor disconnects and VFD. Regular maintenance helps to ensure that the equipment is operating safely and efficiently. Maintenance tasks may include inspecting the wiring, tightening connections, and cleaning the equipment. It is recommended to establish a preventative maintenance schedule and keep records of all maintenance activities. When dealing with electrical systems, safety should always be the top priority. Only qualified personnel should perform electrical work. Always to energize the equipment before working on it and use appropriate personal protective equipment such as gloves and safety glasses. By carefully considering all of these factors, one can safely and effectively place multiple motor disconnects in a single panel door. However, it is always recommended to consult with a qualified electrical engineer or electrician to ensure that the installation meets all applicable codes and standards. Now let's delve into some specific scenarios and considerations for placing multiple motor disconnects within a single enclosure, particularly when VFD are involved. Let's examine cable management. Proper cable management is crucial for maintaining a clean and organized enclosure, which in turn facilitates troubleshooting and maintenance. Use cable ties, straps, or trays to neatly route and secure the wiring. Avoid creating sharp bends or kinks in the cables, as this can damage the insulation and reduce the current carrying capacity. Also, maintain adequate separation between power cables and control cables to minimize electromagnetic interference. Regarding component layout, the physical arrangement of the disconnects, VFDs, and other components within the enclosure can significantly impact its overall performance and maintainability. Position the components in a way that maximizes airflow and minimizes heat buildup. Place the VFD at the bottom of the enclosure as heat rises. Ensure that there is sufficient clearance around each component for access and ventilation. Avoid overcrowding the enclosure, as this can make it difficult to work on the equipment. Furthermore, consider short-circuit current ratings, which are a critical aspect of electrical safety, and it's imperative to ensure that all components within the enclosure, including the motor disconnects, VFDs, and circuit breakers, have adequate short-circuit current ratings. The short-circuit current rating of each component must be equal to or greater than the available fault current at the point of installation. This rating ensures that the components can safely withstand the high currents that occur during a short-circuit fault, preventing equipment damage and potential hazards. In addition, be aware of harmonic distortion. VFD are known to generate harmonic currents, which can distort the sinusoidal waveform of the electrical power supply. These harmonics can cause a variety of problems, including overheating of transformers, increased losses in conductors, and malfunction of sensitive electronic equipment. To mitigate harmonic distortion, consider using line reactors, harmonic filters, or active front-end VFD. These devices help to reduce the amplitude of the harmonic currents and improve the overall power quality. Regarding control wiring, in addition to the power wiring, it's essential to carefully plan and execute the control wiring for the motor disconnects and VFD. Use shielded control cables to minimize electromagnetic interference. Properly terminate all control wires and label them clearly for easy identification. Follow the manufacturer's recommendations for control wiring connections and grounding. Don't forget about surge protection. Motor disconnects and VFD can be vulnerable to voltage surges caused by lightning strikes, switching transients, or other electrical disturbances. To protect these components from surge damage, consider installing surge protective devices, or SPDs, at the input of the enclosure. SPD divert the surge current away from the sensitive equipment and protect it from damage. Be aware of safety interlocks. In some applications, it may be necessary to incorporate safety interlocks into the motor control system. Safety interlocks are designed to prevent accidental startup of the motors during maintenance or troubleshooting activities. These interlocks can be implemented using limit switches, safety relays, or programmable safety controllers. Ensure that the safety interlocks are properly installed and tested to verify their functionality. Consider emergency stop push buttons as well. Install emergency stop push buttons at strategic locations near the motor control enclosure. These push buttons allow personnel to quickly and easily de-energize the motors in the event of an emergency. Ensure that the emergency stop push buttons are clearly labeled and easily accessible. Furthermore, think about remote monitoring capabilities. Consider incorporating remote monitoring capabilities into the motor control system. This allows personnel to monitor the status of the motors, VFDs, and disconnects from a remote location. Remote monitoring can help to identify potential problems early on and prevent costly downtime. This can be accomplished using programmable logic controllers, or PLCs, human-machine interfaces, or HMIs, or dedicated monitoring software. Remember arc flash hazard analysis. Conduct an arc flash hazard analysis to determine the potential arc flash hazards associated with the motor control enclosure. This analysis will help to identify the appropriate personal protective equipment, or PPE, required for working on the equipment. Label the enclosure with the appropriate arc flash warning labels. In addition to all of the above, document everything. Maintain accurate and up-to-date documentation of the motor control system, including wiring diagrams, component specifications, and maintenance records. This documentation will be invaluable for troubleshooting, maintenance, and future modifications. Lastly, be aware of local codes and regulations. Always comply with all applicable local codes and regulations when installing and maintaining motor control equipment. These codes and regulations may vary depending on the location and the type of installation. Consult with a qualified electrical inspector to ensure compliance. By carefully considering all of these factors, one can safely and effectively place multiple motor disconnects in a single panel door. However, it is always recommended to consult with a qualified electrical engineer or electrician to ensure that the installation meets all applicable codes and standards. Remember that these considerations are for general guidance only, and the specific requirements for a particular installation may vary depending on the application, the local codes, and the equipment being used. Always consult with qualified professionals for specific advice and guidance.